Welcome to Textbook Engineering Problem, where we explore complex engineering problems and discuss different methods for solving them. In this video, I'll be breaking down a problem and discussing different ways to tackle it. However, keep in mind that there is no one correct path for some of these solutions, and I encourage you to share your own insights and thoughts in the comments. Together, we can learn and improve our problem-solving skills. So, sit back, grab a notebook, and let's dive into today's problem. Today we're working out of Elementary Principles of Chemical Processes 3rd edition, and we're doing problem number 3.52. I'll read the problem statement. As will be discussed in detail in Chapter 5, the ideal gas equation of state relates absolute pressure, P in atmosphere, gas volume, V in liters, number of moles of gas, N in moles, and absolute temperature, T in Kelvin, by this equation. Part A. Convert the equation to one relating P in psi gauge, V in feet cubed, N in pound moles, and T in degrees Fahrenheit. Okay, so the equation that they gave to us here is in these units, and the part A says we need to convert it into these units. This is a little bit tricky because pounds gauge is not an absolute pressure, and temperature Fahrenheit is not an absolute temperature scale like Kelvin and Rayleigh. So our equation will look a little different. It won't look as nice as this equation here, but we'll go from there. Okay, so what we need to do is we need to write P in atmospheres in terms of psig, liters in terms of feet, and in terms, and so on and so on, until we've gone through every single one of these variables, and then we can just substitute in our new equation. Okay, so let's start off with the pressure. So we know that the gauge pressure is equal to the atmospheres, the absolute pressure minus the atmosphere. Okay, so this is in units of atmospheres. This is the atmospheric pressure, so this would be 1 atm. Okay, and then this is a scaling factor, so we scale the psi into atm. That's what A is. Okay, so we need to rewrite this equation so that it's in terms of P8 in atm. Okay, absolute pressure in atmospheres. So that we can just substitute this P in for this equation. Okay, so that's the first one done. Now we do the volume. This is pretty easy because it's just a unit conversion. I wrote B over here, and then this is the conversion factor. Same thing for moles. We just have a conversion factor to go between moles and pound moles, and that's C. Then we have Kelvin temperature, and then we have this Kelvin conversion, where you should be fairly used to seeing that now. And this is what we started with. PV equals RNT. That's the ideal gas law. Remember, I wrote R up here, R right here. Okay. So then we just substitute in all the values that we had. So this was our pressure, this was our substitution for the volume, substitution for the moles, and a substitution for the temperature. And that's it for part A. Part B. A 30 mole % carbon monoxide and 70 mole % nitrogen gas mixture is stored in a cylinder with a volume of 3.5 feet cubed at a temperature of 85 degrees Fahrenheit. The reading on a Borden gauge attached to the cylinder is 500 psi. Calculate the total amount of gas, pounds moles, and the mass of carbon monoxide, pounds in mass, in the tank. Okay, so now we just use our equation that we used before, and we solve for the number of moles. Okay, so they gave to us the volume, the temperature, the pounds, and this is in psig, because it's a Borden gauge. It's measuring the pressure inside the tank. So that's a gauge pressure. Then we calculate the number of moles using our equation up here. And then we can convert the moles into pound moles of carbon monoxide. Then we use the molecular weight of carbon monoxide in order to calculate the total number of pounds of carbon monoxide in the tank, 2.59. All right. And part C says approximately to what temperature in degrees Fahrenheit would the cylinder have to be heated to increase the gas pressure to 3000 psig, the rated safety limit of the cylinder. The estimate would only be approximate because the ideal gas equation of state would not be accurate at pressures this high. Okay, so we have a new pressure, so instead of using 500 like we did before, we use the same number of moles, because the number of moles doesn't change when you heat and cool the tank, and the volume doesn't change, so the volume stays the same, the number of moles stays the same, temperature is changing, so that's what we're solving for, and they gave us a new pressure. Okay, so you just do the same thing, you solve for what the temperature is, and you get that the temperature is 2,730 degrees Fahrenheit. Well, that is it for problem number 3.52. Thank you for watching, and I hope you found this video helpful in your problem-solving journey. Remember, there are other routes you can take to arrive at the same correct answer, and I encourage you to leave a comment with any additional insights or questions you may have. Also, if you have any specific engineering problems you would like me to cover, please let me know in the comments. Your feedback is valuable, and I look forward to continuing the conversation with you. Don't forget to like and subscribe for more engineering problem-solving videos. Thanks again, and I'll see you in the next video.